This is the pre-lab for the synthesis of para-red. Para-red was first discovered in 1880 in an Austrian textile plant as one of a series of azo compounds. Compounds that consist of a nitrogen-nitrogen double bond with alkyl or aryl groups attached to each nitrogen. As a consequence of pi delocalization, aryl azo compounds, like para-red, have vivid colors, especially red, orange, and yellow. Because of its color, para-red was the first azo compound to be used as a dye. It was first used to dye cellulose fabrics like cotton and linen, but is now mainly used in ink cartridges. It is not allowed by the FDA or European governments to be used as a food dye. Interestingly, in 2005, the UK found traces of para-red in certain foods, the first one being Old El Paso taco and burrito kits. It was soon discovered that some spice suppliers were spiking chili powder and paprika with para-red, which was illegal, to maintain the color of spices. Obviously, this is not done anymore. In this presentation, we will cover the typical material, including the pre-lab assignment, safety information, goals and methods of the experiment, background information about the utility of what are called diazonium salts, compounds used to make aryl azo dyes, how to properly conduct the experiment, and how to clean up. I will then discuss the grading policy for this experiment, which will be quite unique from past experiments. Before coming to lab, make sure you read the assigned sections from Techniques in Organic Chemistry and your Organic Chemistry textbook. You should also set up your lab notebook. The format is preparative. And make sure you follow the guidelines from organizing your notebook found in the experimental procedure. Keep in mind this experiment will extend over 3 weeks and count as 3 experiments. For your safety, understand that nitroaniline is highly toxic and can be absorbed into your skin. Sulfuric and nitric acids are highly corrosive and cause skin burns. Glacial acetic acid can also cause burns when it is hot. Sodium hydroxide is corrosive and also causes skin burns. Do you see a pattern? Lastly, 2-naphthol and para-iodonitrobenzene are irritants. Because of this, you should wear gloves and protective clothing at all times. You also need to be aware that diazonium salts are explosive when they're dry, and they decompose in water when they are warm to room temperature or higher. Make sure your diazonium salt solution that you will eventually prepare is maintained at cold temperatures. The main goal of this experiment will be to prepare para-red along with para-iodonitrobenzene in a multi-step synthesis starting with acetanilide via a diazonium salt. To do this, you will nitrate acetanilide to yield para-nitroacetanilide as the major product. You will then hydrolyze the para-nitroacetanilide to produce para-nitroaniline. Para-nitroaniline can then be diazotized, and the resulting diazonium salt will produce both para-iodonitrobenzene and para-red. To understand how to make para-red, you need to know some information about diazonium salts. These are compounds that are prepared from aniline derivatives. If we treat aniline with sodium nitrite in the presence of a strong acid like sulfuric acid, we get a diazonium salt, in this case, diazonium hydrogen sulfate. The diazonium cation has an electron-deficient nitrogen, making the salt a good electrophile. The mechanism for this transformation first involves the reaction of the nitrite anion with an acid, yielding nitrous acid. Protonation of nitrous acid, followed by loss of water, yields the nitrosyl cation. Aniline attacks the electrophilic nitrosyl ion at the nitrogen, and upon deprotonation forms what is called the nitrosoaniline, Nitrosoaniline reacts further under acidic conditions, and through a series of proton transfer reactions, and subsequent loss of water, yields the diazonium salt. Diazonium salts are extremely versatile in transforming aniline compounds into a variety of aromatic derivatives. Because of the electron deficiency, they behave as electrophiles and can undergo nucleophilic aromatic substitution reactions. They can be used to prepare phenol compounds upon reaction of water, which is why you have to keep your aqueous diazonium solution cold, iodobenzene derivatives, and will react with a number of copper salts, such as copper cyanide, to yield aryl nitriles in a type of reaction called the Sandmeyer reaction. The electrophilic nature of diazonium salts is not limited to the benzene ring. Highly activating benzene derivatives, such as phenols and arylamines with strong electron donating properties, can undergo electrophilic aromatic substitution with diazonium salts. Here, the terminal nitrogen of the diazonium salt is attacked by the activated ring of phenol, yielding the cyclohexadienyl carbocation, which can be stabilized through resonance by the OH group, that upon deprotonation yields an azo compound. Azo compounds are highly colored, and many are used as dyes, as we saw in the case of para red. There are only 7 synthetic dyes that are currently approved by the FDA to be used as food coloring. While para red is not one of them, 3 of these dyes are azo compounds. Red dye number 40, yellow number 5, and yellow number 6 are all azo compounds. This experiment will span 3 lab periods, so we will discuss the experiment and cleanup of each procedure for each period. On the first day, the experiment consists of nitrating acetanilide. Nitration yields both para and orthonitroacetanilide, which I will simply abbreviate as the para and ortho products. We want to maximize the production of the para product, which will be used in the subsequent experiment. To do so, ensure the temperature of the reaction does not exceed 20 degrees. Upon completion of the reaction, you will pour the reaction mixture into cold water. At this point, the precipitate is mainly the para product, while most of the ortho product remains in solution, since the ortho product is slightly more soluble in water due to the asymmetry of the polar substituents on the ring. At this point, you will filter the para product, separating it from the ortho product. You then need to purify the para product by recrystallization. Be careful with how much solvent you use to recrystallize. Good technique will yield well over 2 grams of the product. Poor technique will yield much lower yields. You will only have one attempt to get a good yield, so make it count. After you recrystallize the para product, you need to characterize it by melting point and yield. Have your instructor inspect the product yield and melting point and initial your notebook. As a bonus, if you take the mother liquor from the original reaction mixture and isolate the ortho product, you can obtain additional points. In order to get credit, though, you must show your instructor the product you isolated. To clean up, you need to wash all aqueous filtrates from the reaction mixture down the drain and place the ethanolic filtrates from the recrystallization process in the organic waste container. If you isolated the ortho product after showing it to your instructor, you can simply discard the solid in the organic waste container. Please make sure you keep the para product and place it in your locker. On the second day, the experiment will consist of the hydrolysis of the para-nitroacetanilide that you made previously in aqueous acidic conditions. This yields para-nitroanilinium hydrogen sulfate and acetic acid. The anilinium salt is soluble in water and is neutralized with sodium hydroxide to give para-nitroaniline, which will precipitate out of solution. Upon initial addition of para-nitroacetanilide to water, not much of the reactant will dissolve. Don't be alarmed by this. As hydrolysis proceeds, the solubility of the reaction mixture increases. Once the reflux time is complete and the reaction has cooled to room temperature, you will neutralize the anilinium salt to a pH of 4 to 5. Remember, this is a titration. You are neutralizing all of the residual sulfuric acid and then the anilinium salt. You won't see a big change initially, but you need to add the sodium hydroxide slowly because once all the sulfuric acid is consumed, then you will see a big change in pH. If the pH goes over 5, don't be alarmed again as long as you have added the sodium hydroxide slowly. This means you have a slight excess of base, which will be washed away. Simply filter the product and wash with water. Again, you have to recrystallize the product with ethanol. Be careful at this stage, and you will get at least 1 gram of product. Determine the melting point of the para-nitroaniline, and have your instructor inspect and initial your notebook. To clean up, wash the original aqueous filtrate from the reaction mixture down the drain. Place the recrystallization filtrate into the organic waste. And remember to keep your product, again, for the next period. Day 3 consists of 4 steps. The first step involves preparing para-nitrodiazonium hydrogen sulfate. You will react para-nitroaniline with sodium nitrite in the presence of sulfuric acid to yield the diazonium salt. Remember to keep the mixture between 5 and 10 degrees for the rest of the steps. You will not isolate the diazonium salt, but understand that you will be using this solution in all 3 of the next steps, so leave it on ice the entire time. Because you're not isolating the diazonium salt, there is no yield associated with this step. However, you do need to calculate the molarity of the solution, so you know the amount you are reacting in the subsequent reactions. To do this, you will assume the reaction went to completion, so the number of moles of diazonium salt corresponds to the number of moles of para-nitroaniline you added. The entire volume of the solution can be estimated at around 10.6 milliliters. This will allow you to calculate the molarity. Step 2 involves the formation of para-iodonitrobenzene. At this stage, the diazonium salt reacts with potassium iodide in a nucleophilic substitution reaction to yield para-iodonitrobenzene, along with nitrogen gas. At this step, you will use 2 milliliters of the diazonium salt, or the diazonium solution for the reaction. The reaction results in the precipitation of a brown solid, and a lot of foaming occurs due to the liberation of nitrogen gas. Simply filter, recrystallize the product, and obtain a melting point. Steps 3 and 4 involve preparing para red. In step 3, you will dye a piece of multi-fiber fabric, labeled number 43, with the para red. To do this, you need to prepare a solution of sodium 2-naphthalate by adding 2-naphthol to hot water and then slowly adding sodium hydroxide to the solution until about 3/4 of the 2-naphthol has disappeared. As the 2-naphthol gets deprotonated, the salt is soluble in water and dissolves. The amount of sodium hydroxide is an estimation. But if the solution is too basic, it will disintegrate the fabric. Obtain a fabric strip and soak it in 5 milliliters of the diazonium solution. Transfer the pre-soaked fabric strip to the naphthalate solution, where para red forms in the presence of the fabric, penetrating into the fibers. Rinse the fabric with water, and make sure you save it, stapling it to your lab report. In the 4th step, you will actually be isolating para red as a solid. The first part involves formation of sodium naphthalate in a manner similar to step 3. You will add the solution to the remaining 3.6 milliliters of the diazonium solution to yield a salt, whereby, upon neutralization with sulfuric acid, yields the solid para red, which you can filter. Because the solid will be extremely wet, there is no need to obtain a mass. To clean up, you need to wash the filtrate from the reaction mixture of the para-iodonitrobenzene down the drain and the recrystallization filtrate into a halogenated waste container. Then place all dye solutions in the waste bottle labeled Waste Para Red Solutions. A few notes about the grading policy for this experiment. As I stated previously, the lab is worth 300 points. Since this is the final lab, part of it will be based on how well you perform in terms of yield and purity at each step. Points will be deducted from your lab report based on the following. Questions the instructor feels you should know will cost you 3 points for an answer. You can certainly ask questions, but you will be told whether the answer will cost you points or not. If you do not obtain a suitable yield for both paranitroacetanilide and paranitroaniline, you will lose 10 points for each substandard yield. Also, if you violate any safety protocols or chemical hygiene, including not wearing your goggles or gloves, leaving reagent bottles open, leaving the balance areas a mess, or leaving lab supplies out, you will lose 3 points per violation. Keep in mind these deductions are out of 300 points. There is also the opportunity to get extra points. Remember, if you isolate the ortho product successfully, you can get 10 points added to your total score. Good luck!